Mm-hmm. Okay. You ready, buddies? Okay. You're required to work together on this quiz. Each member of the group must submit his or her own answers in order to receive credit. If needed, here's a link to the normal probability applet. You need soccer shoes and the hot dog nutrition, which is going to really make Miranda's stomach feel awesome.
Yeah.
When calculating anything, please remember to round to 3 decimal places unless otherwise specified. Do not round until your calculation is complete. Okay, in ANOVA hypothesis test, we reject original hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. I have this answer, but I'm just double checking it before I say it out loud.
Okay. You could just say it out loud and just do it with confidence.
This is true.
Yes.
I was so nervous for no reason.
Yeah, don't be nervous. That's what I said. Say it with confidence.
Okay, I'll do better. I'll do this one too. What requirements needed to be checked before performing a ANOVA hypothesis test? Mark all that apply. Sample means are positive. Data in each group is normally distributed. Variances are equal to each group. I know it's definitely number 1. Because they can't be negative, right?
Something can't be negative, but I don't think the sample means is what they're talking about.
One or more of the means differs from the others. I didn't take any notes for this, I feel like.
So I think the sample means can be negative because they're just means. So just really like they can be whatever. If we're working with negative things, they can be negative,
yep.
right?
Okay.
Yep. But it's the
other 2. So it's the data in each group are normally distributed and that variances are equal.
Yeah. And it's also the thing that can't be the thing that can't be negative and it always has to be positive is the F distribution.
That's right. Okay.
That's
Thank
what
you.
I'm thinking about. Yeah. I'll do question 5. To check if each group is normally distributed, do the following. You would construct a QQ plot for each group.
I just want to call those cute plots.
I'll do number 6 too.
Okay.
We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size. And I'm going to say, do you want to answer it, Emma?
Yeah, number 2.
Yeah, good
The
job.
largest.
Yeah, it looks like you were ready, and you're just like, I want to say it. So
I'm just holding my peace sign. I knew that one. Just saying.
Yeah, you did. Good job.
Thanks.
All right. An ANOVA hypothesis test is equivalent. Can you guys hear, like, back? I don't know.
I think Emma's volume is just really high, so that's why
Okay. I just wasn't sure if it was, like, my computer. But I wanted to make sure.
Emma's volume is really high because she can't hear me unless she
turns
it's really high.
I turned it down quite a bit, though.
Okay, can you hear me still?
Yeah, I turned it down to 50, just barely.
Okay.
Just barely? Okay. I just wasn't sure, like, it was because I tried to open SPSS and then I started running everything slow. So, okay, cool.
My microphone sucks, I think.
An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1 and 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples? So there are 4 samples. There's going to be 4 pairs?
I think it's 6. So they have 1 and 2, 1 and 3.
2 and 3.
I think that's if there were 3 pairs, but if there's 4 pairs
There's 4
add 3
samples.
more.
or 4 samples.
I think it's 6.
Your reasoning on that, Emma.
Hold on. It might be more. So we have
8?
1 and everything is 4. We have 2 and 3 and 2 and 4 is 6.
Let's write it down on a paper. So we can,
Fine. We'll get the paper. Here's my giant bag of popcorn, guys.
I need to keep pens over here.
Let's just write it down, just like they wrote the 3s down.
Okay.
Okay, I'm sticking with my 6. Wait, no, I'm not.
One, 2.
Yeah, I'm sticking with 6 for sure.
Yeah, I think 6.
This is what my paper looks like.
2 and 4. Yeah, that's correct.
Yeah. I was just getting confused because I was doing 1 and 2, 1 and 3, 1 and 4, and then 2 and 3, 2 and 4, 2 and 1. But then I'm like, wait, there's already a 2 and 1, so
We can't do that one.
you don't have to repeat it.
Okay. Awesome. All right, guys. This is where I am no help anymore.
Okay. Soccer shoes. The data was collected to help determine how the design of soccer shoes affects the accuracy of a kick. The 5 times of the shoes labeled A, B, C, D, and E, and also wearing socks, a total of 6 groups. Each row represents the kick from 10 millimeters, something away, and the target is hung at 115 centimeters, maybe, from the ground. The column accuracy is a distance in centimeters, maybe. I don't really know what the labels are there.
Yeah.
From where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Use this scenario for the next 5 questions. What is the minimum smallest variance of the 6 groups? Okay, Miranda. So we're going up here. Do we need to do the extra step here that they gave us a hint on?
Yep.
Automatic recode? Okay.
Yep.
Would one of you be able to share your screen so that I can see?
Emma.
Yeah?
Yeah. So I kind of already got it done, so
Oh.
not like
I don't know how to automatic or share my screen. Someone want to walk me through that?
Left-hand side of the screen, there's a green thing that says screen share
For
YouTube.
YouTube or
YouTube.
for
YouTube. Like you can see my
where?
face.
YouTube?
Look at my face and then
I
go to
see
the
it.
left-hand side. Hit screen share and then you hit what you want to screen share.
Thanks.
Are you seeing it? Whoa.
Oh, infinity.
With like the Eternity Mirrors guy.
Yeah.
Are you able to see it though?
Yeah,
Yeah.
I can see it.
Okay. Okay, so I'm coming up here. I'm going to transform this. Automatic recode. Kicking accuracy, right, Miranda?
Nope. It's
Oh, footwear. Sorry.
footwear. Yep. And you have to rename it.
New footwear.
No spaces.
Okay, thank you.
Add new name.
Add new name. Okay, then I have that. Then I'm going to go to Analyze Data, Compare Means, One-Way ANOVA. I'm going to take the new footwear, put it in the dependent list.
Nope.
Oh, okay. Kicking accuracy, dependent list, new footwear, in the factor. Then I'm going to go to options, click descriptive and means plot, continue, okay. And here is our nice graph.
There we go.
Beautiful.
Look at me whiz through that,
That
guys.
was awesome.
That was very awesome. Good job.
I came prepared today. Okay, so what is the minimum smallest variance of the 6 groups? Oh yeah.
Do you remember
don't
what
go into there.
the variance is? Variance is
Wow.
the standard deviation squared.
Standard deviation squared.
So the minimum, Emma, if you can,
So, am I looking right here then?
yep,
Okay,
we're going to look for the smallest one.
so I'm going to say it's C.
Oh, dang it. Yeah, hang on. I totally picked the wrong one.
C 5.216.
216 squared. What did we get?
5.216, yeah?
Yeah.
Yeah.
Okay.
And
Then
then
what is the maximum? So we're looking for the
Oh.
negative.
Emma, no.
Yeah.
The answer isn't 5.216. It's 5.216 squared.
Squared.
Okay, thank you. Let me grab my calculator.
I got 27.206.
That's what I have too.
And then
207.
round to 207. Yeah. That's what I got.
Thank you. Sorry.
No, you're
No,
good.
thank you.
Okay, then what is the maximum largest for the 6 groups?
Looks like that one's the D.
Yeah, the 7291. So do we square this one as well then?
Yep. So that's how you get the variance. It's asking for the variance. The variance is the standard deviation squared. You're going to want to write that down on your
Okay.
notes.
Okay, thank you.
Yes.
So I got 53,159 rounded.
Yes.
Mm-hmm.
I'm just going to write that down really quick, the variance squared. Okay. Question number 10. The test for equal variances satisfied satisfied for these data.
So how do we check that?
Sorry, guys. Hold on. Test result.
We've got question number 4.
Mm-hmm.
It gives us what? Oh wait, let's see.
So data in each.
Yeah, never mind. Question number 4 is basically we have to do that, but
That the variance is equal in each group.
yeah. But the way we do that is in question number 6.
So we're taking 4 times the smallest variance from the biggest one. So we're just taking the 56 minus the 20 minus the 20 minus the 20 minus the 20.
Or you can do 27 times 4 and see what answer you get and see if the 56 is lower than that.
Oh, you're trying to make it easy on us.
Yeah, could you if you wanted to, you could do that, you know. And I got an answer of 108, so 53 is smaller than that, so the test should be equal.
Be satisfied.
Should be true.
Awesome.
And then I've got the screenshots. Hang on. I've screenshotted mine because I have the QQ plots already done. Can you see me? Let's see.
Let me switch over.
This is the QQ plot for group A. This one's for group B. This one's for group C. That one's D and E and socks. Looks pretty normal to me. What about you guys?
Yep.
I agree.
Awesome. Stop sharing.
I'm sorry, can we go back to number 10?
Yes.
So once we found out that it was the over 100, so it was less, then that means that the test for equal variances is satisfied for these is true, correct?
Correct.
Okay, that's what I thought. I just wanted to be sure. Thank you.
Yep. So question 12. Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data? Crap.
Miranda, are you understanding how to understand that or no?
I basically just erased all of the data, the SOX data.
Dang.
I just erased it, and now I'm just gonna go redo it and see what it does. It's not like I can't pull it up again with the SOX data later.
I guess I'm confused at which one is the SOX data compared to the other.
The one that says SOX. Scroll down after E, it says SOX. Will you talk so I can see your screen? I guess I can.
Yeah, I'm seeing it right now.
You
So when
can.
I'm on here, I don't see SOX, but I'm looking right here. Is this
go
wrong?
into the data view. You're in the variable view. Go at the bottom left corner.
Oh,
Yeah.
that's
Scroll
so
down.
fancy.
I was gonna say yours looks a little different. There it is. And I just deleted all of it, even the things that said socks. You can highlight it like Excel and just delete it. Like right click it and drag up or down. Oh, you don't have a mouse, so it's probably a little bit harder.
Yeah. I'm just gonna do it this way.
Okay, sounds good. Ooh, look, you got it. Don't go too high.
Ah, barely.
Good job. And then there's also that group's number. If you go right, and it should be
thank you.
number 6, I think. Yeah, number 6. You want to delete number 6. Yeah.
Jamming out.
What it's all about.
Okay. So then I'm just doing the ANOVA test again, yeah?
Yep.
Okay.
That's what I
So
got.
I'm seeing the. Go ahead.
Oh, sorry. I said that's what I got.
Okay, the 309.
0.309, yeah.
Yep. Thank you.
Hey, Gabby, you could answer this question. Question 13.
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left? The F statistic of the F statistic. I'm not sure actually. I can't remember this.
So
It's on Saturday.
do you know if it's right skewed or left skewed always? Do you remember?
Am I? Left.
Nope. So every time we do an ANOVA, it's always going to be right skewed.
Okay.
That means the F statistic is going to be close to the tail, but we are looking for everything that's right of the F statistic.
Of the F statistic.
Yeah. I think, oh no, I don't. I was going to say I still have the lesson up, but I don't anymore.
Okay, I'm erasing everything from soccer shoes.
Okay, sounds fun. I'll start reading the next question. It says, researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in this file. Ta-da! Use this data file to answer the remaining questions. Question 14. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs. and compare the variances to determine if the assumption to use ANOVA have been met. So we're doing it on calories first. We're going to
We're doing what first, Miranda? I'm sorry.
calories, but first, hold on. I'm going to share my screen and I'm going to have you guys, I did the transform automatic recode already, and I did the type and I renamed it to group. So we did that. So I've got the group here. We've got beef, meat, and poultry. We are first going to analyze, compare means, and then do the one-way ANOVA. We're going to do the calories as the dependent list because that's what we're going to do first. And then we're going to do group as the factor. We're also going to go to options, go to descriptive, and click means plot as well. Hit continue and OK. And this is the information we get. Right now, the question says, compare the variances to determine if the assumptions to use ANOVA have been met. So we have to make sure the standard deviations are not 4 times, like the lowest one is not, the highest one is not 4 times the lowest one or whatever. The lowest one is the 22.551. That squared is 508.54. So I'm just going to times that by 2 and get 1,017. The biggest one is 25,236 squared. Yeah, not even close to 4 times. So the variances are equal. I'm going to say that. Now we need to do the QQ plots, right? Go to explore. We're doing the calories. We're doing factorless as group. Options, not options, plots. Normal plots with test. Continue. Okay. We get this information. And we have this QQ plot. Looks really nice. That one looks really nice. And that one looks really nice too. So I would say they have been met. Safe to assume each group comes from a normally distributed population. Yeah. So I'd say A is probably the correct one because all the rest of them say they have not been met. Dang it, I forgot to clear that. Oh, 2 and 51. Okay, so question 15. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F is 16.074 and P is 0.000. With a level of significance equal to 0.05, what conclusion can you draw? What do you guys think? So basically, it gives all of the information in the question. So
Right.
it should be
We have sufficient evidence to the same number of calories. Hot dog types have different number of calories. I'm just having a hard time with the way that they've worded some of these. They sound the same almost to me.
Okay. So
To claim that all three hot dog types have the same number of calories.
okay. So let's go back and say what was our null hypothesis? What were we trying to say? What was like the null hypothesis? Basically, the null hypothesis would be that all of the means, all of the hot dogs have the same mean.
Calories.
Yeah. So that was the null hypothesis. The alternative hypothesis is that one or more of the means are going to be different.
Okay.
So with this information, are we going to reject the null hypothesis or are we going to fail to reject the null hypothesis?
We are going to reject the null hypothesis.
Yes, so we're going to reject it. So the first one is basically what the null hypothesis is. So that can't be the right answer.
Okay.
So the second one says we do not have sufficient evidence to reject the claim that all three hot dog types.
True.
But that's not true either because we're going to reject it. So the last two are a little bit confusing.
Yes.
So Emma, why would you say number 3 is the correct answer?
Because we do have sufficient evidence that we can claim that the hot dog types are 3 different numbers of calories rather than all of the same.
Okay. Have you read the answer number 4?
Yes. Okay. Maybe not well enough. Have the sufficient evidence to claim that at least one hot dog type has different mean number. Okay, I vote number 4.
Yeah. Do we know that all 3 have a different one, or do we just know that we have sufficient enough that at least one of them
has? Okay.
Yeah, just one. Okay, that makes sense.
Yeah, like it could be more than one, but we know at least one of them is
So that's the most correct answer.
Yes.
Okay.
Yes.
That one was tricky because it was so close.
Yeah. So now we just have to do the QQ plots for the sodium level. Emma, do you want to screen share that and do that?
Yeah,
one?
would you mind walking me through it? Because I'm not sure I know how to do the QQ plots for it.
Yeah.
Okay.
Emma, are you there or are you frozen? She might have accidentally logged out. We're still live though.
Yeah, we are. Oh.
What?
I clicked on Emma and it went to a blue person.
Oh no. She might have accidentally exited out of it. There she is.
That was the scariest thing of my life. I know that I created it.
You're good.
I like all of a sudden kicked me out. That was so terrifying.
It's okay, we're still live, so
Okay,
it's
good.
still recording.
Good.
And you still have access to like stop the broadcast?
Yeah, it still has the red button when
Okay.
I need it.
Okay, good. Then we're good. No worries.
I don't know why it kicked me out. That scared my little heart a lot. Okay. I'm gonna screen share now. Entire screen sharing. Okay, here we go. Maybe. Okay. So I have the new type. Is this what yours looks like, Miranda? This one
yeah,
with the one.
that's yep.
Okay.
Yep.
Okay. Lead me, guide me, walk beside me.
We're going to analyze
Okay.
the data, right?
Okay.
We're going to do the descriptive statistics, and we're going to explore.
Okay.
So we want to do the sodium this time instead of the calories.
Okay. Then we're gonna go to plots.
Nope. We need to do.
Option.
Nope. We need
Oh.
to. Emma, talk again. I can't see your screen.
Oh, I'm sorry. I'm talking right now really loudly. Right
Yeah,
here.
sorry. So the new type, you're going to click on new type and then put that in the factor list. And then that's good. And now we go to plots
Okay.
and hit the normally plots with tests. And
Okay.
hit continue.
Then I'm clicking continue, and then I'm pushing OK.
And then it should bring up tons of plots for you. And it should bring up, and it should, there it is.
Okay, so now we're looking for the QQ plots.
And it should be coming soon. Yeah, just keep scrolling down. Oh, they're processing.
Processing.
Okay, so
That one looks
this
normal.
is number one,
That
number
one looks
2,
normal.
3.
Ooh.
And I think there's only 3 options. There's
Oh.
only 2.
Yeah.
That's just a different plot.
I was like, whoa, they got weird.
Yeah. So it says you should see that the QQ plot for the poultry suggests a possible problem with the normality assumption. So the poultry QQ plot might look a little different. But it looks like it wasn't that bad. It does also say the smallest variance is 7,180.75 and the largest is 10,492.87. Have the assumptions been met to use the ANOVA? So what do we need to do to see if the assumptions have been met so we can use
So we need to take this smallest variance and times it by 4 and see if it's higher or lower than the highest variance.
Yes.
Times it by 4. It's smaller.
Yes. So what answer would we get?
The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population.
I think the QQ plots are fine. Like it did say the fourth one was, or the poultry one was a little off, but I think it wasn't that off.
So it's okay to assume each group comes from a normally distributed population from the QQ plots?
Yeah, that's what I would say, but I don't know, because the variance is are okay. So those check
They're
out.
equal.
Yeah. So the only thing that we wouldn't have is if the variances are not okay.
Okay.
What's up, Jeremy?
Hey, what's with the last minute notice? You guys messing me up.
Well, none of us showed up yesterday, so
I know. I don't want to show up anymore ever again.
Amen. Amen. Remember that one time when you said, "Is there an F statistic?" Well, guess what? Bam! There is.
Oh, for the love. Are you guys started already, or are we still waiting?
Oh, we are so started.
Yeah,
Oh,
we started a little
sorry.
while ago, but
Sorry.
you can help us with the
The last question.
You're on the last question? Oh my goodness.
last. We're on the
Oh, second to last.
I guess there's 18 questions. I thought there were 17, but there's 18.
All right, carry on while I open up my stuff here. I'll catch up. You guys just keep going. Don't wait for me.
Great.
I haven't even opened up iLearn or anything.
Okay, sounds good.
Sorry.
You're good. Question 17. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? So, what are we going to do, Emma? Do you remember?
Do we have to take the poultry and have it be by itself?
No, we just have to do an ANOVA.
No, I don't remember this.
So all we're doing is doing an ANOVA to get the p-value.
Oh, that's stupid. I know how to do that.
Yeah, I'm like, I know you know. You're just a little confused right
Sorry.
now. Just
Okay, compare means and the
Which-
ANOVA. I got this.
I don't think the poultry QQ plot was bad, but I looked on it on Emma's thing. I guess it's a little bit, but
So I guess I'm confused at what goes into the dependent list. Is it the new type? Or is it the
Okay.
factor?
so the dependent list, that's all of the information we have. So that would be the sodium. The factor would be the new type.
New type. Okay. Then we're going to options to make sure that we got those two.
Yep.
Okay. So I have a number here.
Okay.
I have 0.179.
Yep, that's what I have for the p-value.
Okay.
0.17.
So for number 18, we ready to be there yet?
Yeah, Gabby, are you good?
Yep.
So it's asking us if the conclusion, can you draw the mean? Okay, so I think it's number 1 because we have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels. I'm reading too quick again. Okay, hold on.
No, hang on. Yeah, I think so. I always want to say that the first one sounds like a good answer, but we always get it wrong because it's worded differently. The second one, it says we do not have sufficient evidence to reject the claim that all 3 hot dogs have the same mean sodium levels. I think that's what it is because basically we're not saying that the null hypothesis is true, and the first answer kind of says the null hypothesis is true. But the second answer says we don't have sufficient evidence to say or to reject the null hypothesis. We can't say that it's true, but we don't have enough evidence to say that it's false.
Okay,
Does that make sense?
so on the last one then, because we did have evidence that at least one of them was different, that one we can say we have sufficient.
Yes, because we did have sufficient evidence to reject a null
That makes
null
sense to me.
hypothesis.
Okay.
So this one, we don't have sufficient evidence to reject it.
Okay.
So
Makes sense.
that's what we say instead of we have sufficient evidence that it's correct, because we can't technically say that it's true, but we can say that we don't have enough information to say that it's false.
Okay.
It just
that makes
kind of sounds like a double negative, but that's just, I guess, how it is.
I do have one quick problem though here.
Okay.
When my computer booted me out, it didn't save all my answers.
Oh no.
So could
Then we
someone give me
can
the 10 and
quick-
11?
Yeah, we can quickly go through them and also like help Jeremy out a little bit.
Do you want me to submit my quiz to see how we did?
I'm doing that right now, but you can as well if you want.
Okay.
It looks like we got 100%. So good job, team.
Oh yay.
Okay. Jeremy, do you have your quiz pulled up yet?
I got the quiz. I just clicked on the links for SPSS, and it is like going in light speed. No.
Yeah.
I'm still working
Okay.
on getting that open. But
So while that pulls up, there are like the first few questions you don't need SPSS, so we'll just kind of go through them
okay.
again. Of course, the question that 1 and 2 are hopefully true.
Yeah. I'm
Hopefully.
sorry I didn't contribute very much, but I just barely got the email open, so
No, you can contribute right now. Question 3.
I'm contributing. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the other. I would say false. I think they can be, yes, slightly different, but that doesn't mean we have to reject it. As long as it's not too much, right?
I think really what they're saying is we're just wanting to see like exactly if they're really, really separate. So I think it would be true.
Okay,
Um,
I'm going with true.
yeah, they can be a little different, but I think the question's like asking if it's like super different, basically.
Okay. All right, question 4. Stay with us. What requirements need to be checked when performing the ANOVA hypothesis test? I think that they have to be normally distributed.
Uh-huh.
And I think all the means are equal. Nope, that's not on there.
Yeah, so we talked about this one with Emma and Gabby, all three of us. But the sample means can be negative. It's the F statistic that can't be negative. So that one is not checked. But the variants are equal in each group are checked and they have to be correct.
Okay, so it can have two different types of the F stat, but they can be negative, you're saying?
Yeah, so the sample means can be negative, but the F stats cannot be negative.
Okay, so you put 2 and 3.
Yeah, 2 and 3, but not 1.
Okay, number 5. To check if each group is normally distributed the following. QQ plot.
Yes.
Okay, number 6. We assume the variance in each group is the same if the following happens. I would say the same sample size.
It's actually B. The largest variance is less than 4 times the smallest.
Oh, I see that on here. I'm
And then-
looking at this printout from.
Oh yeah, nice.
Yeah, 4
Also,
times.
You want to write variance equals the standard deviation squared. I forgot about that, but that's what the variance is. It's the standard deviation squared. So you might want to write that in your notes. And question 7.
Okay, question 7. ANOVA hypothesis. So that would be, okay, that would be 1, 2, hang on. 1, 2, 1, 3, 1, 4. 2, 3, 2, 4, 3, 4. So I'd say 6 pairs.
Yes.
Okay. Emma, are you done vacuuming?
Almost.
Sorry, that's
I
me.
put a decimal in one wrong spot, so I have to retake my test.
Oh, shoot.
Only
Shoot. Oh, come on. Man, SPSS is awful.
Well, there's some kind of thing wrong with it.
well, no,
Who
it's
said
the
that?
VMware. It's the VMware that's wrong with it. Like that's what's wrong. Is the
Oh,
VMware.
I paid for it though, so I should be getting high quality customer satisfaction type stuff here, right?
Yeah. Emma, how far did you need the answers to?
I've gotten them. I just am rewriting
okay.
them right now. Thank you, though.
Okay, awesome.
Okay, so this one we gotta get the sample minimum variance for the 6 groups. Boy, oh boy. Can't really do this one unless I can open this sucker. So when we get this one, oh, what's it opening? Nope. Something's opening. That's been like 5 minutes. All right, maybe.
So we're all done. Do we want to just end the broadcast and then I can just stay with Jeremy or something and walk, like, go through the rest of the quiz together? Or I feel like we all don't have to be here, right?
I don't mind staying, but
It'll be okay. You guys can go.
okay.